4, 5, and 6, now we're doing the linear relationship and the sample correlation coefficient. The sample correlation coefficient is called R. It gives you a value, and if the value is 1, then my line would be exactly straight. If it's positive 1, my line would be going up. If it's negative 1, it's going down. And so when you do R, when you're doing statistics, R tells you how close to your line of best fit is to your dots. It's only equal to 1 if your dots would all be in an exact straight line. So on this one, my R value would be close to negative 1 because that's going downhill. On this one, again, my line is going to be close to positive 1 because it's going up. Here's my line going down, here's my line going up, but my dots aren't exactly straight. Here, you'll notice that my dots are scattered all over the place. I would be somewhere around 0 because there's no place that I could draw a line that would make sense to be a line of best fit on that one. This one, if you look at your dots are kind of going downhill, but they're scattered out more than your dots here. So this is a negative slope, but it's probably not very close to negative 1 because my dots aren't very close to my line. They're scattered all over the place. So answer the following question about the relationship between the pairs of variables and the values of the sample correlation coefficient, otherwise known as the R value. The same response may be correct for more than one question. Which data sets indicates the strongest negative linear relationship between the two variables? Well, we had 2 negative relationships. This one up here is the stronger relationship because it's closer to the line. And so what they're going to do is use the variables that are given in the table. So they're going to say that figure 1 where I do W to T, W2T, or W, no, that's not W to T. Figure 1 where I do X to Y is the one that is closest. So figure 1 does X to Y, and that's the one that's closest to a negative linear relationship. The second one, for which data set is the sample correlation coefficient closest to 1? In this case, here is the one that's closest to positive 1. My slope is going upwards. So figure 2, which is the variables U and V, so they'll say U to V. Number 3, for which data set is the sample correlation coefficient R closest to 0? Closest to 0 is the one where my points are scattered out all over the place. Happens to be figure 3. They're putting these all right in a row. My variables on that one is the W to T. And on this one it says for which data set is the sample coefficient R equal to negative 1? If it was equal to negative 1, all my dots would have to be exactly straight on my line. In this case, it's close to negative 1, but not equal to negative 1. So my choice here is that none of them fit that answer. There are none that are exactly equal to negative 1. So number 5, below are 4 bivariate data sets and the scatter plots for each. Note that each scatter plot is displayed on the same scale. Each data set is made up of sample values drawn from a population. So in this case, this one has a positive slope. And it's close to positive 1. Again, it's not exactly positive 1 because it's not exactly straight. This one here, it's going to be close to 0 because all my dots are scattered all over the place. There's nowhere I can draw my straight line. Here we go. This one, notice all my dots are exactly straight in a row and it's going positive. This one is exactly equal to 1. And on figure 4, here we have a negative slope. It's not really close to negative 1, but it is a negative slope. And so if we look here, it says which data set indicates the strongest positive linear relationship. The strongest positive linear relationship, both of these are positive, but the strongest one is when it's exactly equal to 1. So in this case, figure 3 which is doing W to T using my variables up here on my table. Number 2, for which data set is the sample correlation coefficient R equal to -1? I don't have any that's exactly equal to -1. I have one equal to +1, but nothing equal to -1, so I say none. This one is negative, but it's not an exact straight line. Which data set has a apparent positive but not perfect linear relationship between my two variables? So in this case, here's the one that's positive, but it's not perfect because it's not exactly equal to 1. It's close, but it's scattered around. So which one has a +1 but not perfect? Figure 1, which is x to y. And for which data set in the sample correlation coefficient R closest to 0? The one that's closest to 0 is the one where my points are scattered all over, which is figure 2. Figure 2, the variables there are u to v. U to v. Number 6. Here again, below are 4 bivariate data sets in the scatter plot for each. Note that each scatter plot is displayed on the same scale. Each data set is made up of sample values drawn from a population. So on this one, notice my dots are all in a straight line. My line is going downhill, so it's exactly equal to -1. It's -1. This one, if I drew my line of best fit, is negative. Didn't quite get that in there in the right spot, but it is negative, but it's not exactly equal to -1. This one, notice I have what has kind of looks like a parabola. It's a quadratic relationship, but it doesn't have a slope of a line that I can give you. And so in this case, I'm going to have to just say, there's no positive or no negative relationship on that one. On this one, if I drew my line in here, again, my line would go positive. My dots are scattered all over, so it's not exactly equal to 1, but it does have a positive slope. So, for which data sets indicates a perfect positive linear relationship? Again, here, when I look at that, I don't have anything that's perfectly positive. I have one that's perfectly negative, and so I'm just going to say none. For which data set has an apparent positive but not perfect linear relationship? Here's the one that has a positive relationship, but it's not perfect, and so that's figure 4. Figure 4 says we have what variables there? I'm having a hard time reading that. M to N. That's what those say. M to N. In which data set is there evidence of a strong nonlinear relationship? Here we have that nonlinear relationship. It's not a line, it's a parabola is what it is. But there's not a linear relationship there at all. And so figure 3 has a nonlinear relationship. That's the W to T. And the last one, which data set indicates the strongest negative linear relationship? This one here that is perfectly negative has the strongest relationship. It's better than this one where my dots are scattered about around my line. So the one that has the strongest negative relationship, figure 1, which is x to y. Can't remember on the drop down, they might just have the variables M to N instead of figure 4 and 3 and 1, but just in case, you'll know which ones I was talking about.